Let's start by getting our formulas from the past video for expected value. That would be the expected value formula, the variance, and the standard deviation. So the following table gives a distribution of the number of interruptions per day in a large computer network. So the 0 interruptions, the probability of that would be 35%. 1 interruption, 25%. So you see what it represents. So how do you find the expected value? Well, the expected value, don't forget, is also the mean. Expected value will be the first x value, which is 0 times 0.35. 0 times 0.35 plus 1 times 0.25 plus 2 times 0.2 plus 3 times 0.1 plus 4 times 0.05 plus 5 times 0.05. Remember, we're summing as we go because we had sigma in our formula. And I used my calculator and I got 1.40. So that's the mean. So the mean is, over the long haul, you can expect to have 1.4 interruptions. Now on the next page, same data, but we're asked to find the variance. And the variance is sigma squared. And what you do is you take the first x value, which is 0, and you subtract off the mean, which we found on the previous page, and we square that, and then we multiply it times the probability. And then we go to the next x value, which is 1 minus the mean squared times 0.25, plus the next x value, which is 2 minus the mean squared times 0.2. Plus, the next x value is 3 interruptions minus the mean squared times the probability, which is 0.1. Plus 4 minus the mean quantity squared times 0.05. Plus 5 minus the mean squared times 0.05. And I used my calculator, and I got 2.04. And then I'm asked to find the standard deviation, and the standard deviation is sigma, and it's the square root of the variance. And I used my calculator, and that gave me 1.4283. Now, in both of these examples, or this one example where we found the mean, variance, and standard deviation, we're given the probability distribution. The purpose of this problem is for us to create our probability distribution. So the probability distribution for tossing a coin 3 times and recording the result. And what I want to record is the number of heads. Number of heads. So let x, the random variable, represent number of heads. All right, so let's do a tree. So you flip a coin the first time and it's heads or tails. We're tossing it 3 times. The next time it's going to be a head or a tail. And this one, let me move it down a little bit. It's going to be a head or a tail. Toss it the third time. Head, tail. Head, tail. Head, tail. Head, tail. Let's practice our, well, I'll do that in a minute. So let's write down our possibilities, our sample space. So I've got head, let me get a brighter color. Head, head, head. Okay? Head, head, head. And now, start here. Head, tail, head. Head, tail, head. Oh, I missed this one here. Let me go back. Head, head, tail. Head, head, tail. Now let's do head, tail, head. Head, tail, head. Head, head, tail, head. I need to be neat. Head, tail, head. Head, tail, tail. Tail, head, head. Tail, head, head. Tail, head, tail. Tail, tail, head. And last but not least, tail, tail, tail. 1, 2, 3, 4, 5, 6, 7, 8. I knew there were going to be 8 because you had 2 choices here. I don't want to write that there. First time you toss that coin, you got 2 choices. The next time you toss that coin, you've got 2 choices. And the third time you got 2 choices. 2 times 2 is 4. 4 times 2 is 8. I used the fundamental counting rule. All right, so let's record the number of heads. So we might have 0 heads, 1 head, 2 head, 3 heads. Now, what's the probability of 0 heads? 0 heads is when you have all tails, and that probability is 1 over 8. How about 1 head? 1 head is where? Here and here and here. 1 head, 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 head. So that looks like 3/8. And what about 2 heads? 2 heads, 2 heads. Here's 2 heads. Here's 2 heads. Here's 2 heads. So that looks like 3/8. And 3 heads is this one, and that's 1/8. And if you add those up, you get 1, so I know I've done well. So now let's find the expected value. That's going to be 0 times 1/8 plus 1 times 3/8 plus 2 times 3/8 plus 3 times 1/8. And I did that work and got 1.5. 3 halves are 1.5. Now let's find the variance. The variance will be the first x, which is 0 minus the mean, squared, times 1/8, plus 1 minus the mean, squared, times 3/8, plus 0, 1, and the next one is plus 2 minus the mean, which is 1.5, squared times a probability of a 2, which is 3/8. Last, 3 minus the mean, squared, times 1/8. And I used my calculator, and I got 0.75. And last but not least, I found the standard deviation, which is the square root of 0.75, and that's 0.866.